This is Euclid Book 1, proposition number 1. Let's get into this, shall we? Now for this, let's go through this. Okay, a few pages, a few more. Yeah. Okay. Yep. That's all. Yep. Alright. Nope. Excellent. On a given finite straight line to construct an equilateral triangle. How are we going to do that? Well, let's begin. Euclid said, let AB be the given finite straight line that is required to construct an equilateral triangle on the straight line AB. With center A and distance AB, let the circle BCD be described. Okay. We are going to put this right here. I'm going to hold it as tight as we can. There's A, and we're going to have a point B right here. Okay? And then we are eventually going to have a point C, but I haven't gotten into that yet. We're actually going to have a point D. We're going to put it, say, right there. Because point D, at this point, doesn't really matter. Okay? Now then, what we're going to do is we're going to draw line AB. I know I just chopped through the B. Forgive me. Okay? Now I'm going to go ahead and zoom in just a pinch. There we go. Now you can see it. Okay. Now then, I'm going to show you point C in just a second. Euclid says, and again, with center B and distance BA, let circle ACE be described. Okay. So now what we're going to do is we're going to let point B be the center, point A be this distance, oops. Alright, now we're going to make our point C. There's point C. I know it's a little awkward, but oh well. Whatever. Can you see it? Yes, you can. Okay. And then we're just going to pick another point right here, because it doesn't matter. There's point E. Okay. So, with center A and distance... Okay. With center B, there's center B, and distance BA right there, so let the circle ACE be described. Well, we did. Okay. And from point C, in which the circles cut one another, to the points A and B, let the straight lines CA and CB be joined. Okay, here we go. This is not going to be perfect, but we're going to do our best. There you go. Now this truly is an equilateral triangle. How do we know this? Because, follow along here. Now, since the point A is in the center of circle CDB, okay, point A is in the center of this circle right here, AC is equal to AB. This line here is the exact same size as this one. That's because all radii of a circle are equal in length. Okay? Again, since point B, this is point B, is in the center of circle CAE, BC is equal to BA. Okay? But we also said that CA is equal in length to AB. Okay? Therefore, each of the straight lines CA and CB are equal in length to AB. This is the same length as this, so this is the same length as this. This is truly an equilateral triangle, and now you can see why. And things which are equal to the same thing are equal to one another. We covered that in the last video. Therefore, CA is also equal to CB. CA is also equal to CB. Therefore, the three straight lines CA, AB, and BC are equal to one another. Therefore, the triangle ABC is equilateral, and it has been constructed on a given finite straight line called AB. And that's the proof. Alright, I will tell you more in a future video, so I'd like for you to stay tuned.